Here we go. Um, so what we're going to crank on today is we're going to continue on our discussion with decibels, but here we go with a couple announcements, real quick. So I know that I haven't posted homeworks two yet. So I'm going to be getting homeworks 2 and 3 posted pretty much at the same time here, but don't sweat. It's not going to be like that hard. Like, I mean, well, I won't say it's not going to be that hard, but it shouldn't take you that much time to get through the two of these. Homework 2 is going to be pretty straightforward. Homework 3 is going to be a little more challenging because it's going to include all this decibel stuff that we're just going over right now and a lot of these numbers in math. The point here is not to bog you down in all the math with this stuff, but it does, if you do embrace it and you do dig in a little bit, it does kind of lend to an understanding of how this stuff works. And for me, at least in my career, in my life, is when I take these little different parts of these elements, these things of like, whatever, physics and math and music and acoustics and my dog and all these other kind of things, they all you start to see these interconnectedness between all these different pieces and parts in your life, and you just start connecting the dots. And for me, that's what the math is, one of those like big time connectors of all these different parts, and also the physics behind the stuff. So that's really kind of the point behind all this stuff, is not necessarily to like just bog you down with the math, because the math is kind of, I don't know. It's if it's the first time you're seeing it, I understand that it can be kind of a drag and it can be confusing and it's not really like that enlightening, so to speak. But the more you do it, if you dig in and you really kind of embrace what it's trying to tell you, like, then that's when the enlightenment happens. So if we think about like math as a separate language, right? And because it kind of is. And math is the language, and that we can use it, but we don't always necessarily intuitively understand it. But it's by using it. But the more we use it, the more fluent we get with it, and then the more understanding we have. And you'll start to see that all of a sudden these concepts that we're talking about here relate to your day-to-day workflow in your music production. And it seems that they're so far disparate from each other that the stuff, the math that we're doing in class right here has nothing to do with you rocking out to some tunes that you're writing, but they actually are very intertwined. And that this math explains all of that other kind of stuff that you've got going on in your life. And so I'm just going to ask you to try to kind of stick with it, bear through it. It's not like this part of the class. We have a fair amount of math, like this section, the decibels. This is the hardest math of the semester, by the way. So, and we will have math, and we'll have like equations, like V equals F lambda. We're going to be using that one all semester, but it's really not that, like, it's pretty straightforward. This is the one that's the one that you have to use your calculator on the most, and it takes a little bit of like just grinding it out to kind of get through it. And the way you learn and understand this is by doing it over and over and practicing this stuff. So I'm just going to ask you to kind of bear with me on this one just for a little while, because it can be a challenge here. So I fully appreciate that. So okay, so class 4, like that one that I did a week ago, like that's one where we crashed. I'm still trying to get that one rebuilt. I haven't had time to re-record that one though, so it's not up yet, which is why I haven't posted homework 2. So as soon as I get that done, I'll get those posted, and I will let you know, and I will let you know what's going on. I always give at least a week for every single thing that I have due in this class. So it's not like I'm going to post this and you have only like a day to do it. I'll post it, I'll announce it, you have a week to do it, and you should be good. So if you have any questions on that, like, hit me up as we go along. So cool. Okay, so what we're going to do today is we're going to continue on with our discussion on decibels. Well, that's where we're going. Right now, we've been talking, I've been hinting at it vaguely as we've been going along here. And we've kind of gone over up to this point things like this notion of ratios, right? So we talked about ratios and comparisons, and we talked about these things like a 10-to-1 ratio, like a 100-to-10 is the same as 10-to-1. The ratio is the same for both of those. But and then last class, we started talking about doing some of these logarithms. And so what we're trying to do is build a picture. So we take these things, this notion of what we call comparisons, and then we're going to take logarithms, and we're going to fold that into this concept of what we call decibels. So just, we're going to get to that in a little bit. I don't want to get ahead of myself right now. So let's continue on and talk about this, well, not really about decibels yet. This slide is out of order. This is supposed to go later. I threw this one in the wrong spot. I want to pick up where we left off when we were doing some of these loggy math, and basically what we'd done is like, we basically type a number in and get the logarithm of it. So let's do one of those real quick here. So Let's do this. Let's take the logarithm of 45. And this one, I'm not going to go to a group. I want to keep moving on this one. I'm not going to go to the breakout rooms for this one right in particular right now. But I want to go ahead and see if you can click in on this one right now. So if you have, yeah, we're recording. So I don't record. I'm recording with ScreenFlow. I don't record with Zoom Recorder. So I record with a different piece of software. So that's why it doesn't show up as Zoom as it's recording, because I use different software for recording. But yes, we are recording. So if I could get you to, at this point, find out what the log value of 345 is. So to do this is you type in 345 and hit the log button on your calculator. So let's do this as a group. See if we can get this as a group. Oh, like it's, let's see. Strange. Huh. And because are you seeing both screens? Are you seeing my other screen as well? Yeah, that's what I'm worried about. Yeah. Builds remaining. Okay. Well, obviously you can get the answer. That's okay for this one. I'm not too worried about that. Oh, yeah. Strange. Okay. So let's see. I wonder. Okay. Well, I'll stop this one. And I wonder if I can do my options from here. Let's see. All right. Well, I'm going to have to, well, yeah, you probably, if you can see the answer, then you can see the answer. So what I'm going to do is I'm going to stop this one and I'll get it started again. But I'm going to try and get it so it only does it in one. Okay, I think I know what the answer is. Okay, cool. Well, let's stop this out. So let's do last call on this thing. And I will save this over here. Let's open this up. Nice. Okay. Yay! Everybody got it. B, because you could see the answer. Nice job. So 345 and okay. I'm going to stop this and then I'm going to get it started again so that basically I can see if I can get it to, oops, stop. Let's cancel this one. And let me get back to it here. Thanks for pointing that out. That's annoying. Let's do this. See if I can get this to settings, devices. No, I guess I'm gonna have to try. Like, let's try this again. Wow, my crashed here. All right, let's get it back up in here. Sorry. Come on. Well, that's annoying if it's not working. There we go. Okay, we'll try it again and let me know if it's still doing the same thing that we did before, if it's screwed up there. So here's a quick trick though. Here's what I want you to do on your calculator. Type in, what's the log of 100? What do you get there? Yeah, 2, right? Because there's 2 zeros. What's the log of 1,000? 3. So we can see that this number right here is between 100 and 1,000. So if 100 is 2 and 1,000 is 3, something between the value of the log value between 100 and 1000 is going to be between 2 and 3. And if you look at this one right here, you can see that this indeed is a value between 2 and 3. Cool. We can't get the exact answer right here, but we can at least, like, if I could do this one, this question here I could do without a calculator, because I know that 100, the log of 100 is 2, the log of 1000 is 3. So therefore, if 345 is going to be 2 point something or other, that in this list right here, I only have a single value of 2 point something or other. So that one I could actually do without a calculator. I couldn't get the 0.54 in my head, but at least could get close. I could get like a rough approximation for this thing. So let's take a look at this one more time, like the logs here again right here. So what we have here is we have the logs of 100,000 is 5. 10,000 is 4, 3, 2, 1, 0. But now what we want to do is we want to say, what happens when we go less than 1? Now, well, try doing this for me real quick. Type in log of 0 on your calculator. What happens? Yep. You can't do it. So you can't take the log of 0. So the number must always be greater than 0, but it can be less than 1. It just has to be greater than 0. So we can have decimal points right here. And so when we move into the decimal points with logarithms, what it does is it moves to a negative right here. So if we think about just like we did here, it says 1, 2, 3, 4, 5. Whoops, wait. 1, 2, 3, 4, 5 decimal points that we have here. How many zeros we have here? We could say that we have 1, 2, 3, and then we're going to the right is a negative value. So we have negative. So if I take the value of a negative, if I take the value of a value less than 1, but greater than 0, remember, it's greater than 0, will give us a negative value. And this is really important. Well, you'll see this come to life here in a minute, but this is a really important concept, that you can have logs of less than 1, but greater than 0. So, and but that just tells you how many decimal points it moves in this direction over here. So let's try this. I'm going to try this again. Let's see if this works, and let me know if it's giving you the answer. Let's try this. Is it still screwed up? Okay. I don't know why that was. That's strange. So why don't we try doing this? What's the log value of 0.005? And this one, again, we can do is... you could probably do this with this one without using a calculator, but for like this kind of stuff, it's just a whole lot easier to use a calculator, right? But what I would also do is like do it multiple times. So it's 0.005 log. So and if you happen to miss last class and if you need to get caught up here, the way you type this into your calculator is you type 0.0005 and then hit the log button. Unless you have a fancy scientific calculator. Does anybody out there have a calculator that you go log 0.005 enter? Is anybody's calculator do that? Okay, yeah, so cool. Okay. Yeah, that's what mine are too. I have like a classic. Actually, I should find that thing. I still find, I keep a regular, I won't say it's analog, but I keep a physical calculator around in the house, and I bought it. Yeah, like whoever knows how many years ago for $15. It's the solar powered one, so it never runs out of batteries or anything like that. And it's really nice to have a fast calculator at your disposal sometimes. And that's not your phone. All right, so it looks like we're still missing a couple of responses here. We're at 58, and we had 62 responses here. So let's see if we can get those in. Okay. So the way you search for it is like, yeah, look for University of Colorado, Denver, and then search for my last name, Merkel. Okay. Okay. All right. Last call. Cool. All right. Last call. Let's see what we got here. Yes. Well done. The answer is indeed A. Cool. And we could kind of use the same algorithm we did last time. So like, remember if we did the value of 500 was positive 2.3 0.005 is negative 0.23. Interesting. Okay. Yeah. Weird. Does that happen to everybody, or is just yeah? Okay. And also, by the way, if you're having phone issues, if your phone is being uh, like like annoying, you can also do this from the web browser. It's just hard because obviously you have Zoom running right now and you're trying to watch this stuff. But you can also run this. You can run Clicker in the browser if your phone dies or something like that. I know, sorry, but you know what? We're gonna be doing enough of these that it's in the wash. It's not gonna make a big difference, so you'll be all right. Like, don't sweat it. You'll be all right. If it becomes an issue, like hit me up on offline and we can address that. All right, cool. So what we've done now, just to kind of reiterate what I was talking about at the beginning of class, what we've done is we talked about this concept of comparison, of ratios. So if I compare this hand to this hand, and remember I said I was using the apples comparison, where if I have 4 apples in this hand and I have 2 apples in this hand, the ratio is 2 to 1, not 2 to 1 apples, just 2 to 1, because it's dimensionless. But then we also have this notion of logarithms. So now what we want to do is we want to combine this idea of ratios and logarithms together to create what we call decibels. And the reason we're doing this is because the logarithms correlate to the way we hear our human senses work. As we mentioned last class, I think it was last class. Yeah, last class we were talking about that when I the sense of touch, the sense of brightness, the sense of hearing, all of these things tend to work on a near logarithmic scale because it takes 10 times to feel twice as loud for something to happen. Or like it takes 10 times the lightness to feel double the brightness. So what that implies is that our senses work on a logarithmic scale. So that's why we've been spending time on this logarithms, because it correlates reasonably well to our human sensory system. And then we're going to use this notion of comparisons because, well, that's all we're going to do. So let's talk about this concept of the decibel. So we call them decibels, but it's a decibel. And if you kind of recognize what's going on in here, the deci means a tenth of a bell. So it's like a decimeter, or like a centimeter, decimeter. Like you can have a decimeter right here. So it's a tenth of a bell. But we're really not going to. I don't want to get too bogged down in the mechanics of that. But let's talk about this notion here. So a decibel is a dimensionless term, and by dimensionless, it's the same reason, because a decibel is a comparison. So let's just say that let's do this here. A ratio is a decibel is a ratio between two values, but we say it's a decibel. So it's a ratio of this to this. So it's a comparison. And because of this ratio business, it's dimensionless. We say decibel, but really what under the hood, it's dimensionless. And that's kind of a hard thing to wrap your head around. It'll come clearer as we go along here. But really what's happening here is we're comparing two different things. And as a decibel, and that's actually above all else that I want you to remember, a decibel is just a comparison. So what is it comparing? And that's what we're going to build up here in a minute. But a decibel is literally just a comparison of two things. And because we're comparing those two things, it becomes dimensionless, that ratio business I was talking about. So that's really all there is. So what are the two things that we're going to be comparing? Well, we can compare from start to beginning, from this one to this one. So like from like input to output, like if we talk about like an amplifier. So like an amplifier, like an audio amplifier, I put voltage in and voltage out. So I can compare the voltage input to the voltage output, and I can get the decibel change, the gain change in there. If I look on a fader on a console, like, I don't have any in here right now. Nope. So if I have a fader, like in a DAW or on a physical console at a mixing desk, what we see is that's given in decibels. And what that's doing is that's comparing the input level to the output level. And that fader right there is going to be determining what the difference between from the input to the output is. And that is in turn going to be given in terms of a decibel, or ratio. So that's how we can do that. But the other way we can talk about decibels is this idea of that we can relate back to a fixed reference value. So instead of from beginning to end or input to output or something along those lines, we could say I have a fixed value, a reference value, and I want to compare what you're hearing right now. So like if I would talk about SPL. So what am I hearing right now compared to the quietest sound that a human can hear? So that's how we use like SPL or like sound level, and we're gonna talk about that a lot here in just a little bit. But when we talk about we compare this to a fixed reference value. So that's that's the comparison we're talking about here. But again, I really want you to just dig in and think that everything we're doing here is we're comparing two different values. That's what a decibel is. So in other words, yeah, how intense is the level you're perceiving now compared to the lowest intensity that you can possibly hear? So let's go back one more time and let's talk about log value calculations again for just a moment. So let's do this one see if you can do this without your calculator, and then double check yourself with the calculator. What's the log value of 1? Anybody remember that one? Yep, 0. Okay, cool. What's the log value of 10? Double check yourself on your calculator. But you get 1, indeed. So we're starting to see this one right here. Cool. Starting to see a trend, right? What's the log value of 20? See if you can do this without a calculator. Just remember going back to what if you can imagine it. So if we know that the log value of 10 is 1 and the log value of 100 is 2, and this value is between the two of these, what is it going to be? So yeah, it's going to be 1 point something or another. And then that's when you do have to go to the calculator, because that one you probably can't do in your head right there. But the log value of 20 is going to be 1.3. Cool. I just want you to get comfortable with this notion of doing these log values, because we're going to be doing them a lot. So, sure. Correct. Yeah. It's not and that's the tricky thing here. It's not a linear system, so you can't imagine it. So yeah, 50, which is in the halfway between those two, is not going to be 1.5. Yeah, because obviously what this 20 is really close to 10 and not close to here, but yet it's 1.3. So if you were to look at it on a graph, it makes a little bit more sense if you plot it out, and you'll be like, oh, that's why it is, because it's got this curve to it. But for right now, without kind of getting in too deep into it, I would say just rely on your calculator when you're having to do these right now. But I would say look at a log graph, and you'll be like, oh, that's the curve on it right here. If I look at the slope on a log graph, it's got a curve to it, and you can see that it's not a linear slope right there. And that's right. So you're absolutely right. So if you do like, actually, let's just do it. What's the log value of 80? I don't know. I don't know this one, but I know it's going to be 1 point something or other, right? Okay, 1.9. So what I would like, just if you want to do this as a mental calculation, is go do the log value of 10, of 20, of 30, of 40, of 50, of 60, 70, and write those down, and you'll see the trend occur over the course of between 10 and 100 at values of 10, and you'll be able to see that happening. So yeah, but good observation that yes, and indeed 50 is not 1.5. Okay. So let's go. Let's put this in. Here it comes. Da da da. This is the intensity. Don't write this one down right now. I don't want you writing this one right like this is a little bit confusing right here. What I'm going to do right here is intensity as a ratio. But what I'm going to do is I'm going to move over to this other one right here and call this the decibel. And so what I'm going to call this one right here is this is intensity level, is what this stands for right here. IL is intensity level. And it looks like a big hairy looking thing, but it's really not that big. So I'm going to rewrite this, condense it. So you don't write this one down either. I don't even want you to remember those last two. These are just like building up to this concept. This is the one I want you to remember right here. This is one of the most important ones right here. So we call this one the intensity decibel. So dB stands for decibel equals 10 log I over I naught. And in this case, what I'm doing right now is I'm saying log base 10. I'm being very specific about the log. And so if you look on because you can do log base values of different, like log base 2, you can do a lot of different log values. For this class, everything that we do here is going to be log base 10. So I'm just going to get rid of this going forward, because because it simplifies things, because it looks confusing when it's in there right now. But I just want to be explicit as we go along here. And when I say 10 log, I mean 10 times the log value of I over I naught. This right here is my ratio. So this is my starting point and this is my ending point. So I'm comparing this to this. This is a ratio right here. Even though I'm dividing these two right here, this is the ratio that comes out of this. So if like going back to my apples calculation, if I have 4 in this hand and 2 in this hand, so this is my 4 and this is my 2, it's 4 to 2 ratio. It's a ratio of 2 to 1 or a ratio of 2. So what we're doing here is this is the ratio right here, and then we take the logarithmic value of that, and then we multiply it by 10. So let's see it. See what I said. No, that this is the 10 times the log over I naught. So what we want, like, it's written in kind of a not funny way, but this is like the shorthand math way of writing stuff. So when I write 10 log, what it means is there's actually a multiplication symbol right in here. So it's 10 times the log value of I over I naught. And what I'm saying right here is I naught is the initial intensity and I is the ending intensity. So right now I'm using I as intensity. So we can use other things in here. We can use voltage, we can use power, we can use other kind of quantities right now. But right now I'm going to keep this confined to intensity because decibels go back to power and intensity as their value here. So, okay, let's put this to work and let's do some. I'm going to run through a bunch of different demonstrations with this thing. Oops, I got the same one in here. I accidentally double that one up again. I don't know why. How did this get copied over? Sorry, I didn't mean to copy these values. Let's see. Yeah, I accidentally doubled up my slides here. My bad. All right, that's the one we want right there. Cool. So here's a key takeaway here. So decibels relate to intensity, power, and other forms of energy. So this isn't going to be like that important to us, but there is an important distinction that comes along here, and I don't want to dig into this too deep because it gets a little it gets more confusing than I want it to for this at this stage right now. But we can say that intensity. So intensity is given in watts per meter squared, and power is given in watts. So when we say I have a 100-watt amp, that's the power. So, and then when we say what's intensity is how many watts per meter square that is. So we talk about this in terms of watts. So these are the two that we're going to be talking about right here. But there's other ones that we're going to be talking about, things like voltage and some of these other ones. But for right now, we want to talk about intensity because intensity is how we perceive sound. When our ear moves back and forth, we hear in terms of intensity. So here's a power decibel. So it looks just like the one that we did with intensity. So dB equals 10 log P over P naught. So P is initial power and P. So this is the starting one down here, and this is the ending one. So if I want to, so for instance, let's use the amplifier as an example again. The power would be like, say I'm putting in the amplifier 0.001 watts. And then the output is 0.1 watts. So this would be the input and this would be the output right here. So this would show us how much difference, or maybe I put in 1 watt into an amp and I'm getting 100 watts on the output, then my ratio would be 100 to 1, which is 100. And then, well, we'll do the math here coming up. I don't want to go through the math too quick right here. So let's do this. Let's build this up. Let's do this right here. So if I start with an intensity of 20 and end with an intensity of 40, what is my change in decibels? So what I'm going to do here is I'm going to switch over and I'm going to share my screen. I'm going to do it. I'm going to share. Let's see. You share. I'm going to do it from an iPad because I find that this is one of those things that's a little bit easier to do with a chalkboard or a whiteboard. So let's do this. Come on. Share. Sharing it. There it goes. Okay. So what I was asking for is the question was, I'm starting. Ah, crap. I already forgot. What was it? It was starting with 20 and ending with, starting with 40 and ending with 20, right? Is that what it was? So oops, let's do this. I equals 40 and I naught equals 20. So I want to put this into my equation. So what I'm going to do is I'm going to go dB equals 10 log I over I naught. So that's my starting, and I'm going to go ahead and write this in here so you can just make it a little more explicit. And I apologize in advance for my handwriting. My handwriting sucks, I know it. Sorry. So what I'm going to do now is the first step is I'm going to substitute in right here for my, well, let's do this. Let's change color for a minute. Let's do that. So this goes here, and this goes here. So what we're going to do is it goes dB equals 10 times the log of 40 over 20. So the first thing I'm going to do now is I'm going to take 40 divided by 20 times log of 40 divided by 20 is 2. So now what I do is I take the logarithm of 2. So I take log 2, and I end up getting, well, actually, yeah. So, yeah, I get log of 2. It's going to be 0.301. And then 10 times 0.301 is 3.01. So what I can say there is that if I start with a level of 20 and I go to a level of 40, that's a 3 decibel change. It's kind of strange to think about that. And that's what we have to start thinking about the other way of describing it. So going from 20 to 40 is 3 decibels. All right. No, so the question is, would the watts be watts per meter squared? No, because actually, remember, it's dimensionless. If I write this in as, zoom in on this, I'll write here. That these it's 40 watts per meter squared divided by 20 watts per meter squared. These cancel each other out. And I'm left with a dimensionless term. And if you recall back when I was saying, a decibel is a dimensionless term. There is no dimension to this. So right now, the question is it going from 20 to 40 watts? In the case I'm saying intensity, but the truth is it doesn't matter because it cancels itself out. It's dimensionless. It doesn't matter. If I go from 20 apples to 40 apples, those cancel each other out because it's dimensionless. So it's kind of strange to think about this stuff, but I'm talking about this in terms of power or intensity. So it could be 20 watts to 40 watts, or it could be 20 watts per meter squared to 40 watts per meter squared. It could be either of those, and it doesn't really matter because they always cancel each other out because it's a relationship. It's just a comparison. It doesn't matter what the units are. They completely cancel each other out. And that's that, like, what? I've never dealt with this before. That's a really strange concept, and it is a really strange concept. So, let's get to share. And let's get back to here. So I'm going to show this thing how I did it again. So what I said is start with an intensity of 20 and end with an intensity of 40. What's my change in decibels? So I did it on the whiteboard, so to speak, and here's how I do it on PowerPoint, so you have a reference for it. It's a little bit more confusing to see it here, but dB equals 10 log, and when I say 10 log, I mean 10 times the log of I over I naught. So I'm going to substitute the value of 40 in and 20 in, because if I start with a 20, this is my initial value, and this is intensity of 40, this is my ending value right here. That 10 log 40 over 20 is 2, and I take the logarithm of 2, and the logarithm of 2 is going to be 0.303. 0.310. And so I say 10 times the log of 0.3 is about 3. So it's 0.301 technically, but we say that it's actually 3 decibels. So what we can say is that that this is 20 to 40. So here's what we can say. So doubling my intensity represents a 3 decibel change. Interesting. So if you wanted to try this, what happens if I put 200 and 400 in here. So if I go from 200 to 400, it's also a 3 decibel change because this is a 2. What if I go from a 2 to a 4? It's also 3 decibels. What if I go from 1 to 2? It's also 3 decibels. So what we can say there is that if I go from 500 to 1,000, that's also 3 decibels. 1,000 to 2,000, 3 decibels. So every time I double, it's 3 decibels and change. So that's a kind of a bizarre concept, but that's, again, the reason we do that, because that correlates back to the way we perceive stuff. So, so yeah, Lucero. So in other words, there's no real value to a decibel. Like we don't exactly know what that value is. What we're saying is we know what the ratio is. It's a comparison, and the reason, kind of what I'm along with what I'm saying right here is that we care about the amount of change. The ratio of change will tell us how much that is, because the absolute value is not what we care about. We care about the amount of change. So we don't care about what the actual units are. We care about how much change there is, because that's how we present. That's how we perceive. That's how human sensory system works. So for me to see, so in other words, for me to see, if I make something 10 times as loud or 10 times as intense, it goes up by 3 decibels. And if I make something, so if I go something like, if I go from like 0.001 watts per meter squared to 0.00 watts per meter squared, that's a 100-fold change. And therefore, if a 100-fold change is a 10 here, well, we'll go through this a bunch. We're going to do this math a lot. So, okay, let's do this again. So if I start with an intensity of 3 watts and end an intensity, I guess I said power, that should be power. So if I start with a power of 3 watts and end with an intensity of 56.7 watts, what's my change in decibels? So starting at 3 watts and ending at 56.7. I need to write that down because I can't, when I switch my screen off, I can't. It makes it much harder to do. So I'm going to go with my I naught is, well, actually it would be P naught in this case, be 3 watts, and P is 56.7. All right, so let's do this. Beat me to the answer if you can. Come on, wake back up. There we go. All right, so I'm going to do a new one here. All right, so what I said in this case, I start at and end at 56.7. So I'm going to do my same thing. I'm going to go dB equals 10 times the log of P over P naught. And so I'm going to start substituting these in. So I'm going to go back to this pink one right here, and we'll say that 3 is our initial value right here. 56.7 is this value right here. So therefore, let's do this as dB equals 10 times the log. Whoops, that's a little confusing. Of, oops, I have this, my bad, I have this wrong here. Let me erase that. I got those backwards, my mistake. Where's my pen? I think that's what I'm using, pink. 56 goes here. 3 watts here. Okay, yeah, I guess I did have that right. So it's going to be 3 over... No, I do have that backwards again. Dang it, I keep doing that wrong. I'm sorry. 56 goes on top. Yes, okay, it is right. Ah, man, I don't know why I keep writing that wrong. My bad. Thank you. It is right. Just second guessing myself. I'm getting caught on technology here. Okay, so I do 56.7 on top and 3 on the bottom. I could put watts in there if I wanted to, but it doesn't matter because they cancel each other out. So then I'm going to go 10 times the log of, and in this case, I'm going to have to, let's do calculator. Where's my calculator? I'll find my calculator. Where is it on here? I don't have it installed on here. That's crazy. I guess it's kind of weird. I don't do calculator on the iPad very often. No, I don't want that one. I just want the regular calculator that comes with. All right. Well, I'm gonna have to do this. Help me out. What's 56? What's 56.7 divided by 3? 18.9. I guess I could do it on my phone over here. So what's the log? So then we do like log of 18.9. Okay. And then we multiply that by 10, which is 10.3. So what we're saying there is that if I switch. Oh, yeah, my mistake. Thank you. I was yeah, I'm getting caught up on my stinking technology. Yes, it is 13. Thank you so much. I appreciate that. Let's see. So if I were to ask you for no, I would usually throw a single decimal point in there. It doesn't like if I were to ask you, I'll say on a quiz question what the value was, it's going to give you a plus or minus range, and so you can, as long as you're within that range, you're going to be fine. So if you decided you want to add, if for whatever reason it was 13.58659, and if you want to add all those decimals in, that works. If you want to just chop some of those off and just show a few like the last couple decimal points, that's fine too. So because this is in kind of the range of like, between 0 and 100 more or less is kind of our decibel values, that I think a decimal point on there would make kind of sense. So I do think that does make some sense in this case. So so this is what I got. So 18.9, the log of value of 18.9, I got, yeah. So I got 12.8. So that other one was rounded to 1.3. And I did mine as 1.28. Close enough. So in this case, dB equals 12.8 versus dB equals 13. In that case, that's pretty close. So it'd be good enough for what we're doing here. So, okay, let's do this. We're going to do a clicker question now, and we're going to do this one as the breakout rooms though. So I do want people to go into the breakout rooms. So write this down. I'll start with an intensity of 4.5 and end with an intensity of 64. What is my change in decibels? So I'm going to go ahead and open this up, and I'm going to ask you to go into breakout rooms, which are breakout rooms. Let's boot this up. Cool. And we got let's do this for 2 minutes, 2 more minutes. So go for it. Hop into that breakout room and double check with your neighbors to make sure that they have the exact same answers that you do. And if you're confused, ask for some help there. So let's see, it's already 30 seconds in. So we'll spend 2.5 minutes on this. In another minute and a half, I'll click you out. Yeah. Correct. Yep, you got it. No, so it's the same. Uh, for intensity and power are the same thing. So the initial is on the bottom and the ending is on the top. Sure. All right, we back. Cool. All right, my friends. So, whoa, crazy. Um, okay. So, okay, let's run through this here. The answer is, oops, I guess I hit stop here. Yay. Yay. Well done, everybody. Cool. So let's talk about how we could do decibels in your head. So this is a little bit confusing, but we can kind of like eyeball it a little bit. So doing baseline calculations can be pretty easy. We've seen this a little bit before. So like, okay, so a tenfold change is how many decibels? So in other words, if I go from 1 to 10, so my ratio would be from 1 to 10. So 10, and we've seen this before, but what's the log value of 10? Well, 1. So so this becomes 1, and then 1 times 10 is 10. So a tenfold change is 10 decibels. So if I double, it's 3 decibels. If I go 10x, it's going to be 10 decibels. So a hundredfold change is how many? So let's walk through this real quick, just doing it in my head. So if I start with 1 down here and I go to 100 here, the log of 100, the 100 divided by 1 is 100. The log value of 100 is 2, and 2 times 10 is 20. So what would happen if I did 1,000 to 100? Well, 1,000 to 100 is going to be a tenfold change. So 100 to 1,000 is 10 decibels. 1,000 to 10,000 is 10 decibels. 10,000 to 100,000 is 10 decibels. So we can kind of see these just relationship, but all we're trying to do is to kind of build this feel of understanding how this is. So if this is 10 decibels, and then this is 20 decibels, how much do you suppose a sixfold change? When I say sixfold, I mean it's a ratio of 1,000,000 to 1. So if I did 1,000,000 here and a 1 here, and I take the log value of 1,000,000, 1, 2, 3, 4, 5, 6, because we know that's kind of the quick way of doing it. We see that the log of 1,000,000 is 6. 6 times 10 is 60. So if I change it by a factor of 1,000,000, that's 60 decibels. Ah, interesting. So this is why we start to use decibels, because it allows us to express a large number, a large change here with just a very small number. And also because the logarithms correlate the way we perceive like the outside world. Okay, what happens when I is less than I naught? In other words, what happens when this value is smaller than this value right here? Up to this point, what we've done is we've had the starting value is smaller and the ending value is larger. Well, what happens if this is smaller than this one right here? So let's do something. Let's do an example right here. So let's say that I is 4 and I naught is 4 and I is 2. So in other words, instead of 4 over 2, let's do 2 over 4. So that basically it becomes that it's 10 times the log of 2 over 4. So dB, or 10 times the log of 0.05. And if you recall, what we did before is that the decimal, if it's less than 1, but greater than 0, we get negative values right here. So and if you go ahead and do this with your calculator, is do it with a 0.5, do a log, take the log of 0.5, and you get negative 0.3. Actually, technically, you negative 0.301. And then when we multiply that by 10, we end up with a negative 3. Interesting. So what we see here is that if I go from 2 to 4, it gives me a positive 3. And if I go from 4 to 2, it gives me a -3. So what it shows is, so in this case, the value went down by 3 decibels. So that's what we're seeing there. And so that this is a pretty, it went down 3 decibels. So logarithms that have values that are less than 1 are negative. So, and then note, you can't perform logs on negative numbers. We already tried that. So the value must always be greater than 0. But that means that whatever value I have here and whatever value I have here, it's like, as long as, like, you can have a negative here and a negative here, but you can't have one of these being negative, because that just doesn't really make any sense. But you can have like this number, the numerator can be smaller than the denominator, meaning that it changes. And so this is what happens when we're looking at a fader on there. It's changing, it's going negative values. So what it means is when the value drops, it goes in negative decibels. And when the value increases, it goes up in decibels. Or when the decibel value is positive, it increased. And when the decibel value is negative, it decreased in intensity. So let's put this to work. Let's do this thing here. So if I start with an intensity of 10, oh, this is already the one we just did. I guess, did we already do this one? No, we didn't do this one, did we? Let's try and beat me to the answer on this one right here. So I'll walk it through it. So yeah, let's do this one. So I don't know why I'm stuck on this 56.7 again. But I think we're just trying to show the change here. So if I start with 10 and end with 56.7, what I'm going to do is I set up my equation here, and I put 56.7 because it's the ending value intensity, and then my starting intensity is 10. That I end up with 5.67 on the. So I'll take the log value of 5.67 and multiply that by 10. So let's take the log of that, and I end up with 0.753. Multiply that by 10, and I get a decibel change of 7.53. Cool. There we go. Now, we want to add a little bit more complexity to this system. The reason we use logarithms is because in decibels, because it allows us to express very, very large and very, very small numbers with a condensed number. So what we want to start looking at, and we start talking about like things like how we use the hearing stuff. So I should have gone over this last time. Most calculators have an EE button, or sometimes it's just an E button, which is like the exponential, meaning scientific notation. So 2 times 10 to the 5th is, at least on the standard Mac calculator, is 2EE5. It could also, like if you're working on a different calculator, it could just be an E, but not small e. So it's 2 times 10 to the 5th is 2EE5. And then if I did 1 times 10 to the negative 12 is typed, and this is how I type it on a calculator, would be 1EE12 negative. So let me do this. I'm going to actually, where is this? No, let's back this up. So, let's see. Let me put mine real quick. So for me, it's this one right here, because I remember yours was working on a Windows system. So for those working on a Windows system, what is the exponential button on a Windows system? Does anybody know? I don't know. I don't have my Windows machine. Yeah, it's EXP. Thank you. So it's the EXP button on a Windows machine. So if I wanted to type in 2 times 10 to the negative 12, at least that's how I do it on my system right here. I go 2EE12 negative. So 2 exponent E negative, or it's like E negative 12. And then I hit equals, and I'll see that I have, to get all the way here, I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is how you write on 2 times 10 to the negative 12. And that seems like crazy, but you're going to have to be doing this a lot when we talk about like our perceptual, because our hearing system is so sensitive. So 2 times 10 to the negative 12. So I want you to do that. Make sure that on your system, you can write 2 times 10 to the negative 12 into your calculator. That's an important one. Because writing this out would be, you can write that out. So if I did clear and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's the same thing. That's really prone to error right there. So what I'm going to write is 2EE12 negative, and then hit enter or equals. And it's because if I write 2EE plus or minus 12, I guess that does work. I usually do my plus or minus afterwards to go positive negative. You could, I guess it does in this case, does work to write negative 12. So, and that would get me the same thing there. So I guess I go 2EE negative 12. That does work, but I tend to write my 12 and then turn it into a negative. That's just how I do my stuff. Okay. Let me do this. All right. We're going to move on. We're going to do this one. Let's see if we can do this quiz question without going into the rooms right now. So I want to see how this goes. So if I start with an intensity of 2 watts per meter squared and end with an intensity of 3 times 10 to the negative 6 watts per meter squared, what is the change in decibels? So let's try this out. So I start this one live. So go for it and see if you can figure this one out. So on the denominator is 0.2. The numerator is 3 times 10 to the negative 6. So you still get, so you get 2 points just for, so the way it works is for clickers, you get 1 point just for clicking and you get another point if you get it right. So you get 50, you still get half the points even if you get it wrong. So it's, even if you don't know, it's just make a guess. So it's a lot of button pushing. And so I would urge you to try going through it more than once just to double check yourself. All right, 2:45. Let's try and wrap this up in 45 more seconds. All right, 15 seconds. Nice. 5, 6, 6. All right, last call. Ooh, nice. Got 6, 7. Anybody else? All right, let's call. All right, so it looks like most people are voting for B, and indeed that is the answer. So let's actually, I'll run through this one real quick so that we can actually see it done, so that we can actually, shoot, that's not what I meant to do. Sorry about that. All right, let's do a new one here. So in this case, my I naught equals 0.2. My I equals 50, was it 3 times 10 to the negative 6? 3 times 10 to the negative 6. So I'm going to go dB equals 10 log I over I naught. I always start with my initial equation. 10 times the log of 3 times 10 to the negative 6 divided by 0.2. In this case, so I'm just going to type it out. So I'm going to go 3 times 10 to the negative 6. Where's my calculator? 3. Oops, I'm going to do sideways. 3 EE 6 negative divided by 0.2 equals, in this case, I could say, I'm just going to leave it in my calculator, but it's 0.000015, or I could also say it's 1.5 times 10 to the 1, 2, 3, 4, 5 times 10 to the negative 5. I hit the log button on that one, and I get 10 times negative 4.82, and that means it's negative 48.2. All right, I know I kind of blasted through that, but I wanted you to see me actually. So, okay, so let me do this. I'll stop my. Let me share my main screen, and I'll do it there, and I'll show you. Share. So, what I did is I start with here. So I'm going to start with my calculator here, and where's my all clear? Cool. So the way I type that in is I'm going to go 3 EE. Oops, not that one. I don't do clear. Let's do this. 3 EE. Is it negative 6? So 3 times 10 to the negative 6 divided by 0.2 equals this one. This is a number right here, which is, I could just leave this, but I could say it's 1, 2, 3, 4, 5. So it's that's the equivalent of saying 1 times 10 to the negative 5. I don't even need to do anything with that. I could just leave that just as it is. But then that's when I have to take the log of that. And so when all I do is take the log of that, and I say log, and I get negative 4.82, and then I multiply it by 10. So, yeah, it's hard. I can't show I can't show both screens at the same time, which is annoying. But basically, so I'll go through this one more time. So basically, the first thing I'm going to do is I'm going to take 3 EE 6 negative, so it's 3 times 10 to the negative 6 divided by 0.2 equals, and then I take the log of that value and multiply it by 10. And that's how I end up with it right there. It's a lot of process. I know. I totally understand. So, oh, go ahead. Absolutely correct. So the question was, do we don't do log of the 3 times 10 to the negative 6 and then the log of 3 times log of 0.2. No, you do the division part first and then take the log value of that and then you multiply it by 10. Does that make sense? Yes. Thanks for clearing that up. Cool. All right. So let's keep this thing going again. So if we look at logs of 10x again, but now we want to do, if we go through and we calculate the decimal values of these things, so the log of 1 is 0. So what happens if I take, so what does that mean for a minute? Let me close this up here. If I start with 20 and I end with 20, what's 20 divided by 20? Right? 1. What's the log of 1? 0. So, and then 0 times 10 is 0. So what that means is if I have start with 20 and I end with 20, that the decibel is 0. If I start with something here and it goes up to 10, like, so if I go 1 to 10 or 2 to 20 or 10 to 100, I get 10 here, and the log of 10 is 1, and 1 times 10 is, right, did I do that right? So if I go 1 to 10, so the log of 10 is, 1, and 1 times 10 is 10. So, sorry, I did that wrong. Yeah, that's correct. Okay. Yeah, I didn't actually type these all out. All I did was just have the logarithms here. But we can see that if we go through, we can start to see that the decibels correlate with this. I don't know why I didn't finish this one out. I kind of have a screw up here. So this is 0 decibels, 10 decibels, 20 decibels, 30 decibels, 40 decibels, 50 decibels. And see, this is negative 10 decibels, negative 20 decibels, negative 30 decibels. So, but again, these are pretty condensed, but when we start working with really, really, really big numbers, this really comes useful. It's because we saw if I went from 1 to 1 million, that's a 60 decibel change. And that's actually kind of the things we work with in real life. But, well, I'm building up to this real life business here in just a minute. All right. So here's the one, and I know that this is like, some people out there are like, oh, this is so complicated. And I get it. It's annoying, but we're going to make it one more level complicated here. What do we have? 5 more minutes here. This is the one that I think confuses people the most by a lot. And if you're already confused, you're like, oh, dude, don't throw this into the system. But yes, this is, we actually want to like back this up, and it's going to get a little bit more confusing here. So what we're going to do here is do what's called anti-log. So what we want to do is if I give you the decibels and I want you to work backwards and find the values of something. So when you're given the decibels, we want to find the intensity or power ratio. So this will make sense in a minute. And I know that this is a lot to take in. So what I'm going to ask of you is, so I'm not going to throw any of this on the homework for this week. I want to expose you to this, but know that I'm available for office hours and I can talk more about this stuff as we go along. Because I know that this is confusing stuff. But here's the thing right here. If you look on your calculator, you'll see that like we have a log button right here, but we also have this button called 10 to the X. So I'm going to use this term. It's called anti-log, inverse log, or anti like 10 to the X. So 10 to the X is the opposite of log 10. So let's do this. What's the opposite of addition? Subtraction. What's the opposite of multiplication? Division. So the opposite of log is anti-log. So it's the mathematical inverse of doing this. So this does get a little bit confusing. So let's well, actually I want to show it to you on the calculator. So let me just show you on calculator right here. So on my calculator right here, these two are right next to each other. This is the inverse of this one. On some calculators, you're going to have to hit, like, if you might have to hit the second to get to the other one. It's like a shift button. So sometimes, like if you're looking on your calculator, you have to hit the shift, and it's usually going to be the shift button on most calculators, like physical calculators, is going to be the inverse of it. So like you might have the log, and then the little 10 to the X is going to be written right above it. I mean, if you hit the shift button to get to that one right there. So what we're going to do here is you just need to find this button on your calculator, and either, again, it might be hidden, you have to shift or something like that, but on the standard Mac calculator, it's just right here. So let's take a look at this. So what I'm going to ask you to do here is, what's the anti-log of 5? We're not going to do this as a clicker. We're going to do this as a group. But what I want you to do is I want you to take so let's do this with my calculator. What's the anti-log of 5? So what I do, so I'm going to do 5 anti-log. So then if I hit log, it goes back to 5. So these two buttons are opposites of one another. So I'm going to hit clear. I'm going to go, what's the anti-log of, what's the anti-log of 5? So clear. Anti-log of 5 is 100,000. 1, 2, 3, 4, 5. So the answer on this one is 100,000. Okay. I'm going to do one more equation. I'm going to do one more problem, and then we're going to call it, because I know that this is probably enough to make your brain melt for one day. It's a lot of mechanics in here, and we're trying to glue a lot of different things like logarithms and decibels and perception and ratios and all this kind of stuff. So I'm trying to try and keep it slow, and we're just bear with me on this a little bit. We just have to get through this thing a little bit. Okay, so 3 dB represents how much change. Well, we already saw this. We know the answer to this one is twice. So how much change? So if I go from 2 to 4, 1 to 2, 10 to 20, so a doubling represents 3 decibels. So that's what we already know the answer to this one. So since we know the answer, let's work it backwards and prove it to ourselves. So what we're going to do here, and this is, so what I did here is I threw a little L2 over L1 because I'm just saying level. It doesn't, I'm just throwing arbitrary. It doesn't matter if it's watts, if it's power, because we know that those cancel out. So I'm just throwing this kind of as a generic placeholder in there. So what I want to do is I'm going to give you, I'm using L2 as generic levels. So I put in 3 dB represents how much change. So I put in a 3 right here. And what I'm trying to do is I'm trying to solve for this value right here, this ratio. So I'm going to go 3 divided by 10. And I'll do this on the iPad too. If I have to, nope, I don't have time. So I'm just going to show this to you, and then we're going to come back next week and we're going to hit on this a little bit more. But 0.3, and then here's the tricky bit right here. This is the one, this from here to here is what confuses everybody. So I'm just going to show it to you one time, and I'll explain it more later because I don't have time for it today. So 10 to the 0.3 is, so 10 to the 0.3 is 2. So I'm going to call it there, and everyone's going, I don't get this. This sucks. I hate this. It's okay. I know if you hate this, that's all right. It's okay to hate this for now. But my goal as a teacher is to make you not necessarily love it, but understand it at least. So let's call it there for now. And we'll come back next week. And so for your job for right now is to look through and read chapter 2. If you like based off of what the information we've gone through today and reading chapter 2, hopefully it'll start to dig in a little bit more and to make a little bit more sense. I'm really slowing it down compared to what chapter 2 is doing, but I want you to kind of have a conceptual understanding. In the end, the math is important. It's understanding conceptually what's going on, but the math really does help understand what's happening here. So with that, my friends, I'm going to call it here. So have a killer weekend. If you have, I'm going to stick around for office hours. But I'm available over the weekend also to chat or whatever if you have any questions or issues or anything like that. But other than that, have a killer weekend. I will see you on the flip side.